It's our last homework review for 9 weeks. But still. All right. Here we go. This is number 1. Ooh, let's move you this way. Okay. So we did this at the beginning of class or similar. Okay. So they give you the first one. So we have this inequality, and they're solving it step by step and justifying each step as they go. Okay, so your different justifications that you could use, specifically for inequalities, there's the distributive property, which they have there. There's the addition property of inequality. And then there's also the subtraction property of inequality. I just don't want to write it all again. I'll put quotes around it. Okay, so subtraction property of inequality, division property of inequality, and then multiplication. Multiplication. I can do this. Property out of inequality. Okay. So you have your addition property of inequality, subtraction property of inequality, division property of inequality, and multiplication property of inequality. Okay, so for here, I don't know where it's better for me to stand. All right. They went from here, 3 times quantity x plus 2 is greater than 15, drew their arrow, and they got down to here, 3x plus 6 is greater than 15. How do they justify that step? Why are you allowed to do that? Because of the distributive property. I'll finish writing it out. Property. Okay. Okay, so all they did was distributed the 3. Bam. Bam. So then I had 3 times x, which is 3x, and then 3 times 2 is 6. Okay. The next step, how do they get from here to here? What did they do to get from here to here? Okay, well, what's different? I noticed that the 6 is missing. What else is different? This number is different. Okay, this number got smaller. So they subtracted 6. Okay, so if they're subtracting 6, what's our justification? We're subtracting, that's the key. We're subtracting, so we use the subtraction property of inequality. Subtraction property. I'll move out of the way in a second. Of inequality. Ta-da! Okay. Boom, filled in that. So that's how we got from here to here, is with subtraction. All right. Now, what do they do from here to here? So think of it as they're solving for x, right? That's what they're doing step by step. They're solving for x. So from here to here, what do? We divided by 3. So we divided by 3 here, and we divided by 3 here. All right. So what is our justification? The division property of inequality. Inequality. Oh, that got a little sloppy. All right, and that's it. You filled in your 2 spots. Bam! Okay. I think we get it, but I'm going to erase this. Yeah, I'll just erase the whole thing. Okay. Real quick, if I had 3x plus 5 is less than 15, and then I get 3x is, there we go. What if I have this? 3x plus 5 is less than 15, and then I get 3x is less than 10. What did they do, and what's the justification? So once can look at what's different. They subtracted 5. Okay. So your justification for that would be the subtraction property of inequality. All right. Okay, pause. Moving on. Oh. Okay, number 2, solve the inequality. Okay, so we're solving, I think it says solving graph. Yes, it does. Solving graph on a number line. So first step is to solve. So you're solving for x. There are a couple different things you can do first. You could either subtract 9 from both sides, or you could distribute first. I always like to distribute, get rid of the parentheses. Okay, so you just multiply what's outside by what's inside. So negative 2 times 2x negative 2 times negative 6 is negative 12. No, it's not. Your negatives cancel each other out. Positive 12. And then all we did was distribute. So then you just rewrite everything else. Plus 9 greater than 13. Okay. Now what? Once again, there are a couple things you could do. What would I do? I would combine my like terms. So I'm going to stay on this side for now, because I like to go one step at a time. So I'm going to combine my like terms. Okay. This is the only one with an x, so he doesn't have any like terms. I can't combine him with anything. But what about 12 and 9? Can I combine them? If I have 12 apples and Jason has 9 apples, yes, we can combine. So then rewrite your negative 4x. We're just going to leave him alone for now. We'll get to him later. And then 12 plus 9, 21. And then rewrite everything else greater than 13. So all I did was combine 12 and 9 to get 21. That's all I did. All right. Moving on. Where's my other color? There it is. So now, once again, we're solving for x. So I want to get all my numbers that have an x on this side, all my numbers that don't, get them over there. So I'm going to subtract 21 from both sides. Now we'll go back to red. So then, once again, didn't do anything to negative 4x. He's being very patient. We haven't messed with him yet. 21 minus 21 is 0. Greater than 13 minus 21 is negative 8. Right? Plus 7. Yeah, okay, negative 8. All right, last step, which we'll do straight again. Now, I have negative 4 times x. You cannot subtract out the negative 4. You cannot subtract out the if it was this, or sorry, if it was like negative 4 plus x, then yeah, I would add 4 to both sides. Or if it was 4 plus x, yes, I would subtract 4 from both sides. But they're being multiplied together. You can only separate them by dividing. Make sure you bring your negative with you. We're dividing by negative 4. Because then negative 4 divided by negative 4 is just 1x, which is just x. And then it's greater than negative 8 divided by negative 4, 2. Your negatives cancel each other out. But wait, there's something wrong. You divided by a negative number. You have to flip your sign. You have to flip your sign if you divide or multiply by a negative. Okay, so there you go. That's our answer. Sorry. So that's your answer. X is less than 2. But then we also have to graph it on a number line. We'll go over here. All right, so I'm going to draw my number line. How far can I go? About there, that's fine. All right, X is less than 2. 0, 1, 2, 3, and then over here, negative 1, negative 2, negative 3. Okay, there's my number line. Okay, less than 2. So is it an open or a closed circle? It's an open circle because it's not equal to 2. It's only less than that. So we put an open circle on 2, and then it's less than, so we go that direction. And that's how you graph it on a number line. This is not a question on your homework because I want you to try some of your homework problems on your own, but this is very close to number 3. Okay? It'll be a very similar process for number 3. All right, I didn't test this one, so we might come out with a decimal because I didn't test it. I just made it up. Here we go. We're solving for x. Notice that you have 2 x's. Okay, you're solving for x. So eventually we want to get all of our x's on the same side. Okay. First thing I'm going to do is I'm going to distribute. I know it looks kind of gross, just take it one step at a time and make sure you're careful when you rewrite things. So then 5 times x, 5 times negative 3, negative 15. And then that's all I'm doing is distributing. I'm going to rewrite everything else. Plus 7 less than 2x minus 1. Okay? Now what do you want to do? I want to combine my like terms. I'm just going to stick on this one side because I like to go one step at a time. So my 5x. On this side, he's the only thing with an x, so I'm going to leave him alone. But negative 15 and 7, I can combine negative 15 and 7. So I'm going to rewrite 5x, leave him alone. All right, negative 15 plus 7 is going to be negative 8. Negative 8. And then, so that was just me combining those two numbers. I got negative 8. And then rewrite less than 2x minus 1. Okay? And then think about what you want to do next. Okay, it doesn't matter. You can either move your x's first or you can move your regular numbers first. I'm going to move my x's to this side. I want my x's to be over here. You can choose either side. but I'm going to move my x's over there. Okay, so subtract 2x from both sides. Okay, 5x minus 2x, 3x, and then just rewrite, minus 8, less than 2x minus 2x, gone. So all that's over here, -1. Don't forget to bring down your negative. Okay. Here we are. So now I want only x's on this side. So I need to get rid of my -8. Right? So then we didn't do anything to 3x, so rewrite 3x. -8 plus 8, 0, is less than -1 plus 8, 7. Oh, see, we're going to get a fraction. That's okay. So in your last step, you're going to divide both sides by 3. You see this? Oh yeah, you can. Almost pulled my whole computer over. X is less than 7/3. You can leave it as 7/3. If you want to change it into a mixed number, that's 2 1/3. So 7/3 is the same thing as 2 1/3. Okay, so we're gonna go. Can you still see over here? No, come this way again. Okay, we're gonna graph it on the number line. Well, actually, let's change it so that it's equal to equal. We'll pretend that it was less than or equal to the whole time. All right, so we are x is less than or equal to 7/3. So here's 0, 0, 1, 2, 3, 4, -1, -2, -3, and so on. Okay. So I'm going to go to 7/3, which is like 2 1/3. So we'll go like right here. That's where it is. And I'm going to put, it's equal to that. So I'm going to put a closed circle there. And then we are less than. So I'm drawing my line that way. And that's how you would graph it. Closed circle because it's less than or equal to. So you have to have a closed circle. All right, now that we've done that one together, you can try number 3 on your own. Okay, here we go. Number 5 is Lillian is renting out a movie theater for a party. Woo woo, party with Lillian. It costs $500 to rent. Cost. So as you're reading word problems, or I would read the word problem completely through, and then go back and pick out your important information. Oh, you can come back this way a little bit. Okay, so your cost is $500. Okay, she already has $180, so if she charges each friend $6.50, how many people does she need to invite to make a profit? Right, so Lillian, she already has $180. Okay, and she charges everyone $6.50? $6.50. Okay. We want to know how many people does she need to invite to make a profit. That means how many people does she need to invite to be more than $500, to make more than $500. How would you set this up as an inequality? You better be thinking about yourself, because I will not be there to walk you through all the test problems. Okay. So she has $180, right? And then she's charging her friends $6.50 per person. You can choose any variable you want. I'm going to use P for people. And then we have this $500. What am I going to put as my inequality sign? Less than, greater than or equal to, less than or equal to. So it says make a profit. So earn more than $500. I want to earn more. I want this to be more than $500. I want that to be greater than. All right? Now, you solve for P. Going to subtract 180 from both sides. I didn't do this one beforehand. Let's see. Oh. All right. And then, so this is gone. So on this side, all you have is 650p greater than 500 minus 180, 320. All right? And then last step in solving for P. You're going to divide by, so you're multiplying P by 650, so you divide both sides by 650. 650 divided by 650 is just P. Greater than 320 divided by 6.5. I don't know. 320 divided by. Oh yeah. So you get 49.23, etc., etc. You get a decimal. 49.23. Okay, once again, what does that mean? How many people does she need to invite to make a profit? P has to be greater than 49.23 people. Okay, so we can't have a percentage of a person. We can't have a decimal of a person. So she needs to invite 50. You round it up. You go up 50 people. She needs to invite, well, she needs to at least invite 50 people to be over $500. Okay? Because P is greater than 49.3. So this is like 49.223 of a person. You can't have 0.23 of a person. Okay, but if you just had 49 people, it wouldn't be enough. So you have to go up to the next one, which is 50. All right. All right. Try number 5 by yourself first. If you need help, then come to me. Okay, we have Bob is a clown. Actually, maybe I'll do a similar one. Yeah, I'll do that. Instead of clown, Tom is a plumber. Is a plumber. He charges $100 plus $10 an hour. Okay, whereas Betty is also a plumber. She charges $70 plus 15 an hour. Betty's also a plumber. She charges $10 plus $15 an hour. When will Betty be cheaper? When will Betty be cheaper? When will Betty be cheaper? Right? Aha, the good thing about a video is you can pause it to write it all down. So I can just keep on going and keep on going. So we have Tom, he does 100 and then 10. This is kind of just for me because I'm going to erase the rest of it. Betty, she does 70 and then 15. Okay, when will Betty be cheaper? Woo! Okay. So Tom charges $100 plus 10 per hour. Betty charges 70 plus 15 per hour. All right. So here I would do Tom's equation. Oh, green's bad. Green's bad right now because of the glare. Hold on. Do 100 plus 10 per hour. Okay, and then Betty, well, Miss Betty does 70 plus 15 per hour. I might have to move you. Oh, just a little bit. All right, I'm trying to figure out when will Betty be cheaper? When will Betty be cheaper? Which way do I draw my inequality? I want Betty to be cheaper. So she needs to be less than Tom. Okay, now you solve for H. So once again, you want to get all of your H's on one side, all of your regular numbers on the other side. I'm going to move this guy. I'm going to subtract 10H from both sides. So then 100, 10H minus 10H is 0. Rewrite your inequality sign. 100 is greater than 70. And then I have 15 minus 10, 5 plus 5H. All right. Now I want to get my H's all alone. So I'm going to move 70. Okay, 100 minus 70, 30. And that is greater than 70 minus 70 is 0. So on that side, you only have 5H. Right? Last step. Wow, this one's going to come out even. Ha! Good for me. Going to divide both sides by 5. Okay, so then you get 30 divided by 5 is 6. 5H divided by 5 is just H. So 6 is greater than H. So when will Betty be cheaper? Okay, so Betty will be cheaper. You can if you like having the H on the other side, you can rewrite it. So this is saying that 6 is greater than H, so you can write it the other way. H This is still 6 is greater than h. If you just like, some people really like having their variable on this side. Okay, so both of these mean the same thing. 6 is still greater than h. Anyways, so Betty will be cheaper when the number of hours is less than 6. So if you're only trying, well, geez, if Betty's gonna, that's most things, if you're a plumber. So if Betty's only gonna be at your house for 5 hours, or if you need a plumber for just 2 hours, Betty's gonna be cheaper. Okay, if you need a plumber for over 6 hours, then you should go with Tom. Okay, so Betty's cheaper when it's less than 6 hours. That's what that means. So that would be your answer. All right. Try number 5 now. It's similar. Okay, once again, because you need to practice this if you don't know it, I'm going to do a problem very similar to number 6. But it's not number 6, but it's very similar. Okay, so you're given a geometric sequence. We're told this is geometric. Okay, we have to fill in the missing values. And we have to write a recursive and an explicit equation for it. Here we go. They give you 2 terms. They give you the 4th term and the 1st term. Okay, so what you do is you take your bigger term, 1,715, and you divide it by your other term, 5. Oh, I should have done this ahead of time. 1715 divided by 5. That's 343. This is going to be a nasty one. All right. I kind of did that on purpose. All right, so 5 times 343 is going to give me this. But you have more than one space to fill, so you have to count your jumps. So 1, 2, 3. So 3 jumps. Jumps equals 3. Okay, you have 3 jumps. So then you take any variable you want. I'll do t raised to the 3rd power, raised by however many jumps. That's just however many jumps, equals whatever you got when you divided. 343. Jeez. What number times itself 3 times gives you 343? So I don't know that off the top of my head. Well, I do know because I set up the problem, so I know the answer. But you can type into Google, it would be 3rd root of, I guess not into Google. You're taking a test. It's not going to let you type into Google. The one on the test won't be this awful to figure out. I guess you can just, if you know how to take, you're going to take the 3rd root of that. If you know how to do it on a calculator, you can do that. Or you can plug in random numbers. So you can go like, well, 6. Okay, 6 times 6 is 36. Times 6 again. I don't know. 36 times 6 is 216. Okay, that's not right. That's too small. So you have to go to a bigger number. Let's do 7. 7 times 7 is 49. 49 times 7. T equals 7. So on your calculator, you could take the 3rd root if you know how to do that. If not, you're just plugging in numbers. But the one on the test won't be as hard to figure out. Anyway, so there, t equals 7. You're multiplying by 7 each time. So 5 times 7 is 35 times 7, I can't remember. 35 times 7 is 245. 245 times 7 is 1,715. And then 17 times 7, 12,005. Okay? So that's how you would do that. So you divide the highest term they give you by the smallest term they give you. I would, yeah. And then count the number of jumps between them. It was 1, 2, 3. And then random variable raised to the third power equals whatever you divided, whatever you got when you divided. Okay? All right, try whatever number that is. That's number 6. And actually, that's all I'm going to do for you. You should have 2 point of intersections in your notes, so look back at those to do the last one. Okay, bye. See you tomorrow.